Zeeshan Ahmed from University of Connecticut Health Center. He will present PROMIS-Med, precise and reproducible omics data management and integrative systems for precision medicine.
Good afternoon, and thanks, Dr. Khan, for a nice presentation today. Today I'm here to introduce you guys our system for the very first time, which is called the PROMIS-Med. And thanks for the introduction. I'm Zeeshan Ahmed, one of the faculty members at the beautiful University of Connecticut Health Center in Connecticut, Farmington. So one of the most trending subjects today in the field of life sciences is precision medicine. And most of us already know that it's about having information of a patient's lifestyle, its medical history, its genomic and phenotypic profiles, and hidden biomarkers. So when we get interested in knowing about its medical history, we are interested in knowing about what kind of diagnosis and what kind of lab tests have been conducted in the past, and what medications and if there is some surgery happened. So the question comes, what precision medicine makes it special? So giving a very rough example, one could say, okay, one medicine which is good for one person might not be good for the other one for the same disease. So further investigating the cause, you might need to look at the genomic profile of a patient. So you have to look encapsulated information within genes, transcripts, mutations, SNPs, and so on. But story never ends here. It goes further. You have to look into the genome profile, epigenome, transcriptome, and going further to the clinical data. So the question is what Zeeshan is doing. We are trying to actually bridge these both fields, which never looks so easy at first. But we have to start our journey from, every journey starts with the first step. So whenever you start some new project, a scientific project, you always come across a lot of challenges. So my talk always starts with challenges because I talk about solutions next, but first we have to see. So as we all know, in most of the organizations, different units exist which performs different jobs, and ultimately we expect them to connect with each other and share the data in a very streamlined and a good fashioned way. But reality is not that nice. So reality is very difficult. So you have different standards, different structures, different files circulating here to there and there to here, which cost you, a kind of, lot of complexities in management of the data, analysis, integration, and so on, which also costs you over exaggeration of the organizational resources in terms of computational power, man, funding, etc. One another problem I would like to talk is my favorite one, which is called healthcare data security. So we all start analyzing the data, but we don't think if we don't have access to data, then what we're gonna do? So the first challenge comes there is HIPAA compliance. Those who are familiar must be smiling. Those who are not, is not less than a nightmare. So it takes around 6 to 8 months only to document what you want to do. I'm not going to talk about all of my challenges. Time is less. So we designed an architecture. I have a little bit software engineering background, and this ugly architecture, which is in front of you, which is not easily understandable at the moment, I designed it. So let's review this architecture. So we designed the system in a way that multiple users using multiple graphical interface based on their profile can interact with the system, because this is one of the requirements from the HIPAA compliance. Second, you have to clearly state what you're gonna do with the data. You have to define the scope of your work, like how you're gonna structure it, how it will be moving between different servers, and and also how within the HIPAA compliance, those servers, you're gonna keep it. Then the real gems come. EHR, electronic healthcare data, genomics data, experiments information. We were also interested in capturing the data at each steps, right from capturing sample, library preparation, sequencing, raw data, processing, pre-processing, QC analysis. We have implemented a lens, and we have also implemented a new concept of embedded pipelines, which I'm gonna talk later today. So it's all connected. Then we have also implemented healthcare analytic process to expedite data analysis in EHR side. And fortunately, we were lucky to have the system we have just recently completed, and we are still working further on it. It's called PROMIS-Med, and it's really taking care of institutional data, healthcare data, LCR data, longitudinal and lifetime data, NGS data, all the data which is associated to that data, all the people interacting and creating studies within the system and analyzing the data using over different GUI features. The whole system is composed of over 35 different modules. I can't talk all of them today, so I just picked 2 of them for you guys. So one is from the healthcare and one is from genomics. Talking about healthcare, one of the biggest issues in healthcare domain is, how you're gonna get the data and move from source to the destination, because data has different structures, different formats, and then it's really, really close to impossible. And in our case, it was over 7,000 tables. So we have developed a software which is dynamically, moving the data between source to destination after cleansing and de-identifying it. Then it's used direct data transfer and also using the HPC data transfer. So this is one of the screenshots of the data transfer. Second main issue is one of the most famous issues today is pipelines. Everybody would like to develop pipelines. Everybody would like to have pipelines. So everybody is in love with their own pipeline, so they don't want to use each other's pipelines. So what concept we have introduced is we thought, okay, what if a non-computational biologist would like to analyze your data, who has no experience with Unix and Linux and those kind of things? We have introduced a one-click data submission, which means we have developed a few pipelines. I'm not going into details now, but we have 3 steps: select the patients and the data, select the pipeline, and submit the jobs. And watch live data processing. Like, for example, a very quick example, FastQ is streaming, FastQ is aligning. You can continuously watch how many reads have been aligned. And that's right now, feedback from the data cluster. So, and you can also have a log of all the processed jobs. So last but not the least, the case study, this very small, example from the system. So this is a screenshot of overall data, how it looks like in state of Connecticut in Yukon Health. We have over 800 patients. I selected the cohort of last 10 years, and we have recently, randomly selected 500 samples, sequenced them RNA-seq using HiSeq, and this is one of the QC reports generated using our system, one-click processing. And then I picked 10 samples from here for today's presentation, and these are the randomly selected samples, so these are some associated disease to that. Then using the system, I did gene expression analysis, and I found one of the sample is really weird and where genes are very highly expressed. Going further detail, I found how many genes, 56,000 plus, how many were over 0 TPM, so a little bit expressed, how many highly expressed. And then I found randomly 3 genes for today's talk. I also found one another gene which was not reported in the medicine record, which was about cancer. Breast cancer, so I validated from the literature that it exists. And then I validated the data from the real medicine records, and we found it's a female, age between 45 to 55. I cannot disclose the real age. And it's Hispanic and Latino, but you can see from the disease gene for type 2 diabetes in Mexican American. I went further inside, I found this lady was diagnosed for 123 ICD-9 codes in last 10 years, and these were the 3 genes-based medicines I found, and I validated from the literature, like the database. Then I found all the medications prescribed to her. So what next? We are coming up with a mobile application for the physicians. Thank you so much, and I would like to also thank my collaborator. You can't achieve anything alone in your life. You have back hands of different people around, so thanks to them. And I'm also coming up with a poster today evening, so I would like to welcome you all there. Thank you so much for your time. It's okay?
Any question?
There's